There are several trends on the periodic table, and this is our first trend that I want to focus on. How big are the atoms? How big is an atom? And so picture the periodic table here, but not the entire periodic table, only the main group elements. And the main group elements are 1A, 2A, and we skip the transition metals, and then we go 3A, 4A through 8A. Okay, so picture those elements kind of here in the periodic, kind of in this box right here. And then we're going to see that with regard to an atom, this makes sense as you go down the group. Okay, so this is going down the group, the size gets bigger. Okay, so that I think totally makes sense. And I'm going to spend some time, a little bit of time at the end of this part talking about why, if you're in the same period, okay, if you're in the same period and you go from the larger atomic number back to the smaller atomic number in the same period, it gets bigger. And we'll talk about why that is. Okay, but one of the things that I emphasized on the previous part is why is an atom large or why is an atom small? It has to do with what the electron cloud is doing. Okay, so that's the size of atoms in the group A elements. So here's a couple of figures to kind of reinforce that. Let's take a look at drawn to, I don't know necessarily to scale, but you can see how if we pick on the group 1A elements, you can see it gets larger as you go down, right? And let's pick on, these are just the group A elements. I'm taking out the group B. And what if I go across the period? Let's pick on period 5. Notice that I start over here with xenon and that gets larger as you go to smaller atomic number, and we're going to have to talk about why that is. So within the same period, it gets bigger as you go from, I say, right back to left again. It gets bigger as you go from right to left, bigger as you go from right to left. Okay, so there are those kind of two trends on the periodic table for the group A elements. And this is just another figure kind of telling you the same thing for the main group elements, the group A elements. And now we actually have a number here associated with, we pick on potassium, that 227 is the radius from the nucleus out to the edge of the electron, or the electron cloud. And that 227 is in picometers. So 227 picometers is the radius of potassium atom. So I have a little video here. Let's see if it plays. Should.
The radius of a single chlorine atom is defined as 100 picometers, which is half the distance between the centers of the atoms in a Cl2 molecule.
So see how we can actually, so this is remember chlorine is a diatomic element. Cl2 is the formula for chlorine, molecular chlorine. And we can, I think I can draw on this. Okay, if the radius is 100 picometers, okay, then when it connects with a fellow chlorine atom, you bump up 100 picometers, and then we get the bond length between the nuclei as 200 picometers. That's all that's saying. Let's see if I can get back to the show here. So along those lines, this is kind of showing you some kind of average or estimated lengths between atoms as they bond together. These are two carbon atoms that are bonding together. Okay, their bond length is 154 picometers. We kind of already covered this one, about 200 picometers, the Cl2, and this is the carbon chlorine one. Not so surprising then maybe if you take half of this added to half of this, you get about 176.